Ladies and gentlemen, thank you for standing by. Welcome to the TServer for Cisco Call Manager JTAP Logging conference call. During the presentation, all participants will be in a listen-only mode. Afterwards, we will conduct a question-and-answer session. At that time, if you have a question, please press the 1 followed by the 4 on your telephone. If at any time during the conference you need to reach an operator, please press *0. As a reminder, this conference is being recorded Thursday, October 15th, 2009. I would now like to turn the conference over to Mark Como. Please go ahead, sir.
Hello, my name is Mark Como. I'm from the Americas Support Team at Genesis Lab. As stated, today's presentation will cover the Cisco Call Manager JTAP logging and troubleshooting. With the latest 2 releases of Call Manager, the name has been changed from simply Cisco Call Manager to the Cisco Unified Communication Manager. Regardless of what type of PBX is being used, this information that we'll cover will remain relevant. Today we will cover the following topics: what JTAP is and how it fits into the architecture with Genesis, what the startup procedure of TServer and JTAP client looks like from the log standpoint, configuring logging to capture information relevant to the troubleshooting process. In addition, I will cover an example of configuration of logging. Finally, I will review a basic call flow showing how to tie events from the TServer logs to the JTAP logs. First, let's look at what Cisco JTAP is. JTAP stands for Java Telephony API and is the main link used for Genesis to work with the Cisco platform. As is obvious from the name, the JTAP link is Java-based and will require that Java be installed on any host being used to run the TServer. The architecture has the JTAP client acting as an intermediary between TServer and the Cisco platform. During the startup of TServer, the JTAP process is spawned. I will cover the details of this startup process in a moment. One final thing to note is that the TServer and Cisco Call Manager reside on separate hosts, with the JTAP client residing on the same host as TServer. The startup process of the Cisco TServer is very similar to all other TServers, with one twist. During the startup procedure, it will launch the JTAP client. This client, of course, is acting as the communication process between TServer and the Cisco platform. TServer does have some control of the JTAP process in that we are able to pass options to the JTAP process through options in the configuration of the TServer. This configuration is done in Configuration Manager. These options can control various properties, from timeouts and heartbeats to logging. Additionally, it is possible to configure, via Configuration Manager, options to control various aspects of the Java environment in which the JTAP process will be executed. So next we're going to start looking at the startup process from the TServer standpoint. So looking at the startup logs themselves, they will appear to be the same as any other TServer. That is until we launch the JTAP client. On the slide you can see an example from the Cisco TServer log showing the launch of the client. In the logs you will see displayed details of the client. First, of course, is the CTI host to which we are connecting. This should be the IP of the Cisco platform. Next, you will see the username and hidden password. This user is the user created on the Cisco platform. The user will be associated to all DNs which the TServer will monitor. Finally, 3 more pieces of information are displayed which may be useful for the troubleshooting process. These are the JTAP version, listed here as 6.1-12. The Java version, here listed as 1.4.2 release 19, as well as the host operating system, in this case Windows 2003 on a 32-bit platform. After seeing the details of the client to be launched, we will next see options which are being started. With these settings you will be able to see which are applied and which fail. In the example given, I have an example of each. For the failure, I will cover the details of why this option failed when detailing logging options. The next section of the logs will list all the properties for JTAPI. In order to find this section when troubleshooting, simply searching for the string printing all JTAPI properties should locate it in the logs for you. If all your settings are correct, the next message will relate to the successful connection of the link, as can be seen in the message above. The link connected message will include the version of JTAPI protocol that is being used, and it may differ from the version in the startup of the TServer, as the server may require us to use a different version. In the server, in this case, I'm referring to the Cisco platform. Once the link is connected, we will of course generate an event link connected message in the TServer, which will be distributed to all clients at TServer. From this point, the process again resembles any other TServer. Clients will register for DNs, and the TServer will propagate events to all its clients. Next, we're going to look at the startup process from the JTAPI standpoint. So looking at the startup process of JTAPI client, we will get a slightly different view of the same procedure and events. The JTAPI log begins immediately with the information that will be very useful for troubleshooting. First in the log, you will get the exact version of the JTAPI client being used. Next, the connection information will be listed. This will, as with the TServer log, include the timeouts being used by the link, the username being used by the link to connect, as well as the IP of the Cisco platform. One thing I will make note of is that the version of JTAPI listed at the start of this log is the version that is being used. So looking at the previous two screens, we saw that the TServer requested to use release 12 of the JTAPI link. The Cisco came back and said to use 13. This process, the JTAPI process itself, would start with 13. The connection request above would be the next thing we see in the JTAPI logs, and they will include the options that we want to use. I don't show the full message because there's a lot of options that are passed, but this is the main request, and it will always look like this. It's the provider open request. It will include options. Again, there'll be details of the link, the IP of the Cisco platform, the JTAPI version, application ID that will be used, and a few other pieces of information. We will get a response back that will tell us the options that we will use. This is part of the negotiation process between TServer and CCM to negotiate the functionality that is available. The final message we see is a message confirming that the link has been opened. And once this occurs, of course, the link is up. Once the link is open, the JTAPI client will request the link capabilities from the Cisco platform. The Cisco will respond with its abilities. These options will, of course, be used to determine the tasks that TServer will be able to complete. These options will be different between versions of Cisco, as capabilities have changed throughout the generations of Call Manager and Communication Manager. Next, there will be a lot of activity in the JTAPI logs where we will receive a list of DNs for which the username is configured in TServer is associated with. Provided by Cisco, this will include the DN and MAC address, as well as configurations specific to the DN, such as type and capabilities. Key here is the fact that only the DNs associated to the JTAPI user we are connecting with will be visible to TServer. A common issue encountered is that when a new DN is configured in an environment, it is not associated to the JTAPI user. When this occurs, we will get no events, and the DN is not in fact visible to TServer, leading to missing events and possible call flow issues. Once we receive the list of DNs, TServer will request line information for each line. This will request the current status of the DN from Cisco. Cisco will respond with all the information on the state of the DN, and TServer will then mark the DN as in service as it receives responses. Now that we have covered the startup process itself, let's look a little bit further in depth on how to configure logging in order to be able to troubleshoot the startup process and any other issues in the environment. I will cover the options and what they do, as well as give an example configuration. This slide shows the basic detail on how to configure logging. Listed are all the options you should configure in order to enable logging in your environment. I'm going to cover each section and major option in detail in the following slides. The first option, key to logging, is the Use Trace File option. This option controls whether to log JTAPI to a file. With this option set to false, of course, logging does not occur. The first key to logging is to enable this by setting it to true. The next 7 options configured control all the different aspects of logging. Each of these options will enable a specific aspect of logging. When enabling logging, it is normal to set all of these options to true so that all aspects of logging are captured by JTAPI. It doesn't add much in the way of load to the server to capture all logging. So the first couple options beyond actually enabling which logging is enabled are the options for the path. First option, trace path, specifies the base directory in which you want to store logs. Directory, the second option, will name the directory within trace path which you would like to store your files. Having these directories separate is useful for configuring multiple JTAPI clients on the same host. Having the same trace path with different directory settings would have the logs in the same general location, but still differentiate them. In the example, you can see that we have the directory set to ts_ccm and the trace path set to c:/genesis/logs/jtapi. Given these options, we would store the logs in c:/genesis logs jtapi and then the ts_ccm directory. Building on the previous options, we have the file name options. These are file name base and file name extension. The file name base option defines the structure of the name. When logging, this will be the root of the file name and will have a log number and a file extension attached to it. The extension is defined by the file name extension option. This is normally called .log, but is configurable, so could of course be changed to anything. This builds on my previous examples to show that with the full configuration, we would get a file named my_ccm_jtapi with the log number .log stored in the directory we had previously defined. Finally, the last 2 options are with regards to log retention and log size. The first option is trace file size, and in order to be valid, must be divisible by 1,048,576. It's defined in bytes, by the way. That is the equivalent to 1 megabyte. Second option, num trace files, defines how many logs are kept before they are purged. So going back to the example I had from the startup process of the failed option, you can see that I had a value of simply 10,240. which of course is not divisible by the number previously stated. So when it failed, it defaults to the default of 1 megabyte, or 1,048,576 bytes. Going back, as I stated previously, the numtrace file defines how many logs are kept. I'll just make note that log retention and having it set up previous to any issues can be key for troubleshooting issues. If defined, it makes it easy to go back and review issues that may have been gathered, since oftentimes it's not possible to detect or predict errors before they occur. So I'm going to finally go over an example configuration. In this configuration, logs will be retained for 30 log files at 5 megabytes per log. The logs will be stored in the e:\/gcti/logs/ccm/6.1/jtappy directory. All of the different loggings are enabled. One thing to note is that I have simply used the directory option defined as a period. What this will do is store the logs directly in the trace path configured path. This configuration would be the same as if you defined trace path as e:\/gcti/logs/ccm/6.1 and directory as jtappy. So the configuration on this slide will be equivalent to the configuration that I will show on the next slide. So you see I have moved the jtappy path from being in trace path and moved it to the directory path. One thing I'll note is all of these options are defined in Configuration Manager in a section that you will need to create. By default, when Cisco TServer is installed, jtappy logging is not enabled. So you do need to create a jtappy section and then add all the options. The options are all case sensitive, as it's Java, and Java is, for a large part, always case sensitive. So next we're going to cover the procedures key to tying jtappy logs to TServer logs. In order to cover this, we're going to look at a basic new call flow. I will go through both the TServer and jtappy logs simultaneously, as well as describe the process to tie the call ID in TServer to the call ID in jtappy logs. This new call is hardphone initiated, so the first thing we'll see in the logs is a create call from the Cisco platform coming into TServer. During the call making process, the receiver of the phone is lifted, which generates an off hook. Next, we generate a dialing with no other DN. The reason for this is we have not made a call yet, but simply have lifted the receiver off the hook of the phone. At the same time, in jtappy, we can see the following messages are generated. First, a new call message, then a state change to dial tone, and then going into an active state with the dial tone. All messages in jtappy will have a few key pieces of information. This includes the GCID, which is the Cisco equivalent to our call ID, as well as the DN and line ID, which is seen as the characters SEP followed by the MAC address of the phone. One of the key things to tying logs together is to have a number searchable in both logs. This is not a completely simple task, but with a little bit of work, it is quite easy for jtappy and TServer. I will cover the process of going from TServer call ID to the jtappy GCID. If you have a CID from the TServer logs, which is listed as 214-80230, in order to get the equivalent Cisco ID, You would first, using a program such as Calculator in Windows, change the number from a decimal to a base 8 or oct number. Once you have this number, it will include the ID of the CCM instance number of the cluster. So the leading digit is going to be the cluster ID. Most often this is 1. You will need to remove the number from the results of step 1. So in this example, 214,80230 in decimal becomes 121,741,446 in base 8. The 1 at the start of this number represents the cluster number and will need to be removed. The number, of course, becomes 217,41446. Taking this number, which is still base 8, we need to change it back to decimal, and we get the GCID found in Cisco, which is 4703014. To go the other direction, you simply need to reverse the procedure and would simply add the cluster instance number as a leading digit in step 2. Now that we have managed to tie JTAPI to TServer, it is just a matter of matching the events. Having dialed 3000, you can see that the Cisco first moves the call to an offering state. This simply means that Cisco is communicating with the phone to see if it will accept the call. It is not ringing yet. Following the offering, if the phone is willing to accept the call, we will see an accepted. This message, in fact, tells us the phone is ringing. One thing to note is the fact that the GCID is listed here. This is the number we received from the call ID located in the TServer logs. Also, the CID listed in the JTAPI logs is not the same as the call ID in the TServer logs, which is also noted as CID. In the TServer logs, you will see a listed CID, which is the call ID that we match to the GCID in JTAPI. Just wanted to avoid any confusion from a GCID in the JTAPI logs as well. Next, in the JTAPI logs, following the accepted message, we will get a ringback provided to the calling party so that they hear a ringing sound on their phone. In the TServer logs, this will translate to a ringing event, or an event ringing. Note on this slide you can see both GCID from the JTAPI logs and the call ID, or CID, that we translated, and you can see that they match up so that we know that we're looking at the same call. Finally, we can see the call answered in both logs. The JTAPI will display this as a connected message, and the TServer will generate an event established. From this point on, the call will proceed. So, bit of a shorter presentation, but this concludes the presentation on Cisco JTAPI procedures. So I'd like to take this time to go over a few other resources that are available to you. Genesis University offers a range of courses that can help you with troubleshooting both of Cisco and other products from Genesis. Details can be found at the address listed. Also available online are our knowledge base and solution search. You can also sign up for weekly notifications about new or updated products by subscribing on the technical support website. If you would like to provide your feedback, please send an email to the listed email address on this slide. Finally, I'd like to thank everyone for attending. At this point, I'd ask the operator to step in to be able to set us up for a Q&A session as well. I'd like to ask now if the operator could step in to start up the QA session.
Thank you. Ladies and gentlemen, if you'd like to register a question, please press the 1 followed by the 4 on your telephone. You will hear a 3-tone prompt to acknowledge your request. If your question has been answered and you would like to withdraw your registration, please press the 1 followed by the 3. If you're using a speakerphone, please lift up your handset before entering your request. One moment, please, for the first question. And our first question comes from the line of Doug Volkin from Landing Tree. Please proceed.
Yes, in your review of JTAPI events and the JTAPI log file, how closely do those events duplicate the switch events that are actually shown in the TServer log?
I'm pretty sure I understand the question. Like, are you talking from the standpoint of naming convention?
Well, in the TServer log, I will see events from the Cisco call manager. Often they're they have various types of bracketed prefixes like GC, TMI, T out, and so forth, and then following that will be something very close to a JTAPI event. And
yes,
I was just wondering if this is a duplication of what's in the so when I read the TServer log, is this a duplication of the JTAPI, or is this another Genesis interpretation of the JTAPI event?
It's going to be a mix of both, but in the end, the best way to describe it is a Genesis interpretation of the JTAPI message.
Okay.
They should match up, and one thing to note is because the JTAPI process is launched by TServer, they are going to, the timestamps in both logs should be pretty well identical.
Okay. So there may be a few milliseconds difference due to network latency.
No, there shouldn't be any network latency actually between the JTAPI client and TServer because they're on the same host.
Okay.
They should be. I rarely ever do I see them actually even different at all.
Okay. Okay, great. Thank you.
And there are no further questions at this time. And there are no further questions at this time. Please proceed your presentation.
Okay, well that concludes the presentation. So if there are no other questions, I've been answering a few on the QA with the meeting as well. But that actually concludes my presentation.
Ladies and gentlemen, that does conclude the conference call for today. We thank you for your participation and ask that you please disconnect your lines.